capital A. Next question. Capital A is equal to the set of x belongs to z integers. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A will contains total 13 elements. Next, capital R is equal to ordered pair of A comma B such that modulus of A minus B is multiple of 4. Here, number 1, we will show that it is reflexive, for which modulus of A minus A is what? 0. 0, it is multiple of 4. Means how? Since 0 is equal 4 into 0. 4 into 0. It is multiple of 4. Therefore, ordered pair of A comma A, that is belongs to capital R. Therefore, capital R is reflexive. Next, symmetric. Number 2, symmetric. Let ordered pair of A comma B, that is belongs to capital R. Means what? Means modulus of A minus B is multiple of 4. Multiple of 4. Means what? That is modulus of A minus B is equal 4 into any integer, whereas M belongs to Z. Just like that. So whenever modulus of A minus B is multiple of 4, modulus of B minus A is also multiple of 4. How? For example, modulus of out of 0 to 12, we can take any two numbers. For example, 1 comma 5. Modulus of 1 minus 5 is what? 4. It is multiple of 4. Similarly, modulus of 5 minus 1 is also 4. It is multiple of 4. 4 means 4 into 1. So therefore, that implies ordered pair of B comma A is also belongs to capital R. Therefore, for ordered pair of A comma B belongs to capital R, B comma A is also belongs to capital R. Therefore, capital R is symmetric. Capital R is symmetric. Capital R is symmetric. First of all, next, number 3. Let for transitivity, let A comma B, that is belongs to capital R, and B comma C, it is also belongs to capital R. A comma B belongs to capital R means what? Modulus of A minus B is multiple of 4. Multiple of 4. So that is, we can write it as A minus B is equal something 4 into M. Just like that. We can write the modulus or without mod. Next, what does it mean? Modulus of B minus C is multiple of 4. That is B minus C. B minus C is equal to something 4 into L. Whereas M belongs to Z. Here L belongs to something Z. It is Z. Okay. Now A minus C is equal to, we can write it as A minus B plus B minus C. So A minus B equal to 4M plus B minus C 4L. So that is equal to 4 common M plus L. That is equal to 4 into, say, L plus M value K, whereas M is integer, L is integer, L plus M is also integer, therefore K must be belongs to Z. So what does it mean? A minus C is multiple of 4. So that implies modulus of A minus C is also multiple of 4. So that follows, it follows that ordered pair of A comma C belongs to capital R. Belongs to capital R. Therefore, if A comma B and B comma C belongs to capital R, then A comma C is also belongs to capital R. Therefore, capital R is transitive. Therefore, capital R is transitive. Hence, R is reflective or reflexive, R is symmetric, and R is transitive. Hence R is an equivalence relation. Okay, this part is over. Next, find the set of all elements related to 1 in each case. Means in this case. So what is that? What is the question? Find the values of small a, so that modulus of a minus with 1 is multiple of 4. This is the question. So therefore, we are going to find the values of a, so that modulus of a minus 1. So modulus of a minus 1 is equal to multiple of 4 means out of the given 13 elements, first you represent which elements are multiples of 4. 0 is multiple of 4, it is multiple of 4, multiple of 4, multiple of 4. So 0 or 4 or 8 or 12. So therefore modulus of a minus 1 equal to 0. What does it mean? A minus 1 equal to 0. So a value 1. Next, modulus of next case 4. Modulus of a minus 1 equal to 4. That implies a minus 1 equal to plus or minus 4. Plus or minus 4. So that implies a minus 1 equal to plus 4 or a minus 1 equal to minus 4. So that implies a is equal to 5 or a is equal to minus 3. Minus 3. Of course, this is not belongs to the set, given set, main set capital A. That's why we are going to ignore that minus 3. Further, next, modulus of a minus 1 equal to 8. So that means a minus 1 equal to plus or minus 8. Therefore, two cases will be arised, plus 8 and a minus 1 equal to minus 8. A minus 1 equal to minus 8. So a equal to minus 7. So in this case, a equal to minus 7. Of course, it is not belongs to capital A. Now we are going to ignore that minus 7. So in this case, a equal to 9. It is belongs to capital A. We are considering that 9. Next, last case, modulus of a minus 1 equal to 12. So that implies a minus 1 equal to plus or minus 12. Therefore, a minus 1 equal to 12, a minus 1 equal to minus 12. So a equal to 13. A equal to 13. No, it is not belongs to capital A. It is not belongs to capital A. And a equal to minus 11. It is also not belongs to capital A. Now, out of these 8 cases, let us take the values for A so that they are belongs to the given set capital A equal to 0 to 12. So 0 case, A equal to 1. Next, plus or minus 4 case, A is equal to 5. It is 5. Next, in this case, A equal to 9. It is 9. Next, another case, no element is there. Therefore, A is equal to the set of 1, 5, 9. Other elements are not belongs to the given set capital A. Hence the problem. question number 11. Capital R relation is defined as like that, and main set capital E is set of all points. Here capital A, the set of points in a given plane, okay. Capital R is equal to the set of P one point, Q another point in capital A, so that the distance of P from the origin is same as the distance from Q, so that OP is equal to OQ. Already I said number 1 equal, number 2 same, number 3 similar, number 4 parallel, number 5 congruent, means this symbol. If the question contains these words, then definitely it is an equivalence relation. Remember, of course, this is the shortcut. For example, here is equal symbol is there. Definitely capital R equivalence relation. Of course, we are going to prove like that. Next, same. Some capital A, capital B, RPQ are two persons living in the same locality, are working in the same locality. Same word is there, definitely it is equivalence relation. Next, similar means especially it appears in triangles, similar triangles. It is also equivalence relation. Next, parallel lines, set of lines, parallel lines, then it is also equivalence relation. Congruent to congruent means its symbol is like that, so it is also an equivalence relation. Remember for other competitive examinations. Okay, now we are going to prove capital R is an equivalence relation. So first reflexive, second is symmetric, and third one is transitive. So first reflexive, number 1 reflexive means capital P comma P means I am telling that OP is equal to OP. It is true for all different positions of capital P. So it is true. So definitely P comma capital P, that belongs to capital R. P comma P, actually P comma Q condition OP is equal to OQ. So P comma P means OP is equal to OP, comma, whereas O comma P, that is from the main set capital A. Okay, so therefore definitely capital R is reflexive. Capital R is reflexive. Next, number 2 symmetric relation. Symmetric. Let ordered pair of P comma Q, that is belongs to capital R, that is belongs to capital. What does it mean according to the question? OP is equal to OQ. OP is equal to OQ. For all O comma P comma Q, it is from the main set capital A. So that implies we can write it as OQ is equal to OP. Of course, both are same in geometry. So that implies ordered pair of Q comma P is belongs to capital R. Therefore, for ordered pair of P comma Q, that is belongs to capital R, Q comma P is also belongs to capital R. Therefore, capital R is symmetric. Now we have to show that capital R is transitive. For which first let us assume P comma Q, that is belongs to capital R, and Q comma capital R Capital R means we can take any letter because already the letter R is used. That's why I wish to change one letter Q, comma T, just like that. It is belongs to capital R. So what does it mean? OP is equal to OQ according to the given condition. OP is equal to OQ. So what does it mean? It is OQ is equal to OT. So therefore from these two equations OP is equal to OQ, that is also equal to OT. Therefore OP is equal to OT, which follows that P comma T, it is again belongs to capital R. Therefore whenever P comma Q and Q comma T, that is belongs to capital R, then P comma T is also belongs to capital R. Therefore clearly capital R is transitive. Capital R is transitive. Hence capital R is reflexive, symmetric and transitive. Therefore it is an capital R is an equivalence relation on capital A. Okay, this part is over. Next second part. Here look at the board. Second part. Further show that the set of all points related to capital P, of course P not is origin, is the circle passing through P with origin as center. Listen, let us take one already capital O, capital P. For example, capital O, capital P, and again it is belongs to the main set capital A. Capital A is what? Capital A is what? The set of points in a given plane. Okay, O comma P comma Q, that is belongs to capital A. According to if whenever capital R is defined as OP is equal to OQ, OP is equal to, so since capital R is an equivalence relation on capital A, we have OP is equal to OQ. OP is equal to OQ means O, it is O, P, it is the point in the given plane. We are taking another point capital Q. We are taking another point capital Q. Of course, it is belongs to given plane. But here the condition is OP is equal to OQ. OP means this distance. OQ means this distance. So it is nothing but it is locus of capital P or capital Q. We can say like that. So what I am telling that OP, let it be constant distance, say small r units, and OQ say constant distance, it is small r. What I am telling that capital P comma capital Q are moving from O at constant distance, say r units. It is nothing but the definition of the circle. In the definition of the circle, what did I say? The locus of point which moves so that at a constant distance from the fixed point, or the locus of Q is the locus of the point capital Q which is moving at a constant distance smaller units from the origin. Hence, so it follows that the locus of capital P or capital P, the locus of capital P or capital Q is the circle, whose center is at origin. So therefore, hence the set of all points related to capital P, Related to capital P means it should be equals to another point. We have taken Q in the same plane, OQ. Related to the point capital P means OP is equal to OQ is the circle passing through capital P. This is the circle which is passing through capital P and whose center is at origin. Hence the problem. Here capital A is the set of all polygons. Set of all polygons. Polygons means it may be, so it may be all triangles or parallelograms or just like that, pentagons, just like that. Okay, so capital A will contain so and so number of triangles, so and so number of parallelograms, so and so number of pentagons. Pentagon means having 5 sides. Similarly, so and so number of figures having 6 lines, 7 sides, 8 sides, just like that. It is the set total capital A. Okay, capital R. Capital R is what? Capital R is equal to the set of ordered pair of first polygon, second polygon. So that P1 and P2 have same number of sides. P1 and P2 have same number of sides. Same number of sides. P1 first polygon, P2 second polygon. P1, P2 having same number of sides. Same. Already I said in the previous question, same, parallel, similar, equal, congruent, just like that. These are all represented by equivalence relation. It is already I said the shortcut. Now, of course, for board syllabus, for board level, we are proving like that. So, number 1, we have to show that capital R is reflexive. So, for which P, capital P, it is belongs to capital A. Capital P is a polygon. So I am telling that here P and capital P will have the same number of sides. Same number of sides means what? If P is a triangle, then P is a triangle. If P is a parallelogram, it is also the same parallelogram. So therefore, what does it mean? P comma P, that is belongs to capital R. Therefore, capital R is reflexive. Is reflexive. Next, number 2, symmetrical. Symmetric means first letter P comma Q, or we can take P1, P2. It is your choice. We can change the letters also. So that without a loss of generality. P comma Q, it is belongs to capital R. What does it mean? It means that capital P polygon and capital Q polygon will have P and Q will have the same number of sides, not the same sides, number of sides. Means, for example, capital P is a parallelogram, definitely capital Q is also a parallelogram. Here we are talking about number of sides only. For example, capital P may be a square, capital Q may be a rectangle. Here we are not talking about the nature of the polygon, nature of the parallelogram. Just it contains, if it contains 4 sides, then Q will contain 4 sides. If P contains 3 sides, then Q will contain the 3 sides. And we are discussing only number of sides, not the nature of the polygons. Okay, so that implies we can write it as Q and capital P will have the same number of sides. So that means ordered pair of Q comma P P that belongs to capital R, because both polygons will have the same number of sides. Therefore, for capital PQ that belongs to capital R, that implies Q comma P is also belongs to capital R. Therefore, capital R is symmetric. Capital R is symmetric. Capital R is symmetric. Capital R is symmetric. Next, transitive. Number 3. Transitive. Number 3. Transitive. What is that? Let first, according to this definition. According to this definition. So let capital P comma capital Q, capital P comma capital Q, or we can take P1, P2, P2, P3, just like that. So that belongs to capital R, and capital Q comma capital R, that is belongs to capital R. Sir, this letter and this letter is same. That's why I am willing to change this letter. For example, T. So capital P one polygon, capital Q another polygon, capital Q that polygon, and T is another polygon which is in capital R. Okay, what does it mean? Capital P and capital Q have the same number of number of sides. Here also capital Q and capital T will have the same number of sides. Means what? Capital P is a triangle, Q will be the triangle. When Q is triangle, then T will be the triangle. Another example, if capital P is a parallelogram, definitely capital Q will be the parallelogram, because the hypothesis, given hypothesis is like that. Next, Q already parallelogram, definitely we are taking another parallelogram, so that it will have the same number of sides. So therefore clearly capital P and capital T that belongs to capital R, because parallelogram, if it is parallelogram, then it is parallelogram, thus it is parallelogram. If capital P is triangle, then Q will be the triangle, then T will be the triangle, thus PT. If P triangle, then T is triangle. If P is parallelogram, then T will be the parallelogram, like that. So therefore clearly capital R is transitive. Capital R is transitive. Capital R is transitive. Capital R is transitive. So here capital R is reflexive. Capital R is symmetric. Capital R is transitive. So R is satisfied three conditions or three postulates, namely reflexive, symmetric and transitive. Therefore definitely capital R is an equivalence relation on capital A, on capital A, on capital A. A is what? A is what? Set of polygons. Set of polygons. Set of polygons. Okay. Next, another part is there. What is the set of all elements in capital A related to right angle triangle T with sides? Okay, 1 minute. Capital T is A. Capital T is A. According to the given data, the sides are 3, 4, 5. So we are very familiar with these numbers. These are the Pythagoras sets. What I am telling, that T is a right angled triangle. Right angled triangle. What I said in transitive property, third point, capital P triangle, then Q will be the triangle, thus T will be the triangle. So therefore here T is a triangle. Definitely capital A will be the set of a triangle. So therefore capital A is the set of triangles. Since capital T, it is belongs to capital A, or we can say that capital T is subset, hence the problem. Here capital L be the set of all lines, so capital L, it is the set of all lines in XOY plane, and capital R defined as capital R is equal to the set of L1 comma L2, so that L1 is parallel to L2. Already I said in shortcuts parallel, then definitely this relation is equivalence relation on set of lines. Okay, listen. Number one. Actually, we have to show that first reflexive. Reflexive means every line is parallel to itself. This is the most important point in geometry. Mind it. Don't say every line is perpendicular to itself. Remember this point. So we can write every line is parallel to itself. That's all. Therefore, if line L that is belongs to capital L, then L comma L must be belongs to capital R, since L is parallel to L, because this reason. So therefore capital R is reflexive. Capital R is reflexive. Next, number 2, symmetric. Let L1 comma L2 belongs to capital R. Means what? L1 is parallel to L2. That is, this is L1 parallel to means this is L2. So clearly we see that L2 is parallel to L1. So therefore, ordered pair of L2 comma L1 also belongs to capital R. Therefore, for L1 1 comma 2, L1 comma L2 belongs to capital R. 2 comma 1, L2 comma L1 is also belongs to capital R. Therefore, capital R is symmetric. Capital R is symmetric. Next, third one. Next, transitivity. So let L1 comma L2 that is belongs to capital R, and L2 comma L3 belongs to capital R. So according to given hypothesis means parallelism. So that implies L1 is parallel to L2. So it means L2 is parallel to L3. Here, this is L1. L1 is parallel to L2, means L2. Here, L2 is parallel to L3. L2 is parallel to L3. So clearly, L1, L3 are parallel lines. So therefore, clearly L1 is parallel to L3. Therefore, L1, L3 also belongs to capital R. So therefore, capital R is transitive. Capital R is transitive. Therefore, R is reflexive, R is symmetric, and R is transitive. Therefore, hence capital R is an equivalence relation on means capital L on capital L. Okay, this part is finished. Now 1 minute. Actually, given line is y is equal to this one 2x plus 4. Actually, what is the definition of parallel lines? Slope of L1 is equal to slope of L2 equal to slope of L3. It is the parallelism. Means, for example, two lines are there. If slopes are same, then these two lines are said to be parallel. What about C value constant? Means that here actual definition. So this is L1. Next, this is L2. This is L2. This is L2. So this is L1. This is L2. Observe. This angle are same. That's why these two are parallel. And we notice that the y-intercept, for example, this is capital C. This point will be capital D. Then y-intercept of first line is OC. Y-intercept of second line is OD. Both are different. So OC not equal to OD. Both are different. What I am telling that two lines are parallel, that y implies the slopes are same. But y-intercept is different. Y-intercept are different. So therefore parallel lines will be of the form y equal to x plus something c1 within bracket c1 not equals to 4. C1 not equal to 4. Next, y equal to x plus c2. Mind it, c2 not equal to 4. Different. It has a different constant. Y equal to x plus c3. So c3 it is different from 4. Y equal to x plus c4. So c4 is differ by 4, just like that, and so on. So therefore, the parallel lines of the given line y equal to 2x plus 4 will be of the form y equal to 2x plus something constant, y equal to 2x plus something constant, different constant, y equal to 2x plus something different constant, just like that. So therefore its general form, general form will be y equal to x plus c, whereas c is any constant, it is different from 4. So therefore find the set of all lines related to the line. Related, what is the relation? Parallelism. What is the relation here? Parallelism. So therefore y is equal to x plus c, whereas c not equals to 4 is related to y is equal to x plus 4. This is the answer. Hence the problem.